Okay, number 5. So a car is stopped at a traffic light, and a truck is coming up behind it, moving at a constant speed. So when the car starts leaving the intersection and increasing its velocity by accelerating, that it does it at the same instant the truck passes it. So they're both starting at the same initial position. And the truck moves at this same constant velocity, and the car accelerates. So we know the initial velocity of the car is 0 and the truck is 8.9. The acceleration for the car is 1.7 meters per second squared and the truck is 0. And the displacement is the same for both. So if I just call them both d, the question is, what is that displacement and when they're equal? All right, so let's see here. For the car, since there is acceleration, well, we could use the same equation for both. Displacement equals initial velocity times time plus 1/2 acceleration times time squared. And for the truck, let's see here, we don't know what the time is, so we got two things that we don't know. But we know that it's going to have to happen in the same amount of time, in the same amount of distance. So t for each of them is the same also, because it's when the car catches up with the truck. So the truck, delta x, or d, is equal to simply its constant velocity, or average velocity, times time. So we can say that since these two displacements are the same, we can set them equal to each other. So the average, this is average velocity for the truck. So that's 8.9. So let's just put a little t underneath so I know that that's truck. So average velocity for the truck times the unknown time is equal to the initial velocity of the car, which is 0. So this whole term goes to 0 because of that. So it equals 1/2 the acceleration of the car, 1.7, times t squared. Oh, so 8.9t equals, let's see, 1.7 divided by 2 is 0.85, 0.85 t squared. So 0 equals 8.9 t, that would be negative, plus 0.85 t squared. So if I factor out a t, then t is either 0, oh, let me actually factor it out. So this is equal to what? So this is equal to t times negative 8.9 plus 0.85 t, and that's equal to 0. So I have a t equals 0, meaning they're at the same place at the same time at the very beginning, which is true because here's the car and here's the truck, and the car is sitting here and the truck's coming by and passes as the car starts. So that makes sense. And the other t is, let's see here, is at 8.9 divided by 0.85. So 8.9 divided by 0.85 is 10.47 seconds. So 10.47 seconds later is when they cross. And I think I just answered part B. So this is the answer to part B. So there's nothing that says you have to answer questions in the order that they're asked. You just answer them the way it works out, that you can figure it out. So this is the answer to B right here. Can we use the answer to B to find A? Sure. We know that the truck is going to travel a displacement of 8.9 meters per second for now 10.47 seconds. So we take our answer, multiply by 8.9, and the answer to A is 93.2 meters. So the displacement The amount of distance that it takes the car to catch up with the truck is 93.2 meters. So that's the answer to A. Part C, what is the car's speed when it catches the truck? Oh. So part C, final velocity equals initial velocity plus acceleration times time. The initial velocity of the car is 0, its acceleration is 1.7, and it does that for 10.47 seconds. So the car's final velocity is equal to 0 plus 1.7 meters per second squared times 10.47 seconds, which gives us, so 10.47 times 1.7 is 17.8 meters per second. Not so bad when you put it all together.